Okay, let's dive right into this. Welcome to today's Explainer. We're going to be unpacking the massive and frankly kind of complex web of our global environment. We're taking a huge journey today. We'll start with the on-the-ground reality of threatened biodiversity, the animals actually fighting for survival, and travel all the way up to the cutting-edge energy solutions that are literally being deployed right now to save our planet. There's a ton of incredible data to cover, so let's get right to it.
Here's our roadmap for today. First, we'll look at the state of wildlife. Then, protecting our ecosystems. Third is global climate action, followed by the pollution problem. And finally, powering the future.
So, Part 1, the state of wildlife.
To truly understand what's at stake here, we really have to look at the charismatic animals right on the front lines of survival. The IUCN Red List, that's basically our global gold standard for tracking extinction risk. But what's super relevant right now is how nations are taking this data and making it local. Take India, for example. They're actively preparing their very own national Red List roadmap. Their firm goal? To publish complete red data books for both their unique flora and fauna by 2030. That's a huge deal for local conservation.
Let's zoom in on a specific example. Take the sloth bear, a true native of the Indian subcontinent. Now, these guys are incredibly unique. They're solitary, they're nocturnal, they eat termites, and get this, unlike a lot of other bears, they don't actually hibernate. Yet, even though they are such specialized survivors, they sit squarely in the vulnerable category. They've been hit really hard by habitat fragmentation, and their global population is now sitting at fewer than 20,000.
Now, what's really fascinating here is the stark contrast in survival status between two populations of the exact same species. The cheetah, you know them, the world's fastest land mammal, and a big cat that, surprisingly, doesn't even roar. Well, the African cheetah population is considered vulnerable, largely holding on in places like Namibia. But its cousin, the Asiatic cheetah, it's critically endangered. Actually, it was officially declared extinct in India way back in 1952. Today, it basically just clings to existence in the arid regions of eastern Iran. It's a tale of two very different realities.
And we see a really similar geographic split with lions. The Asiatic lion, which you'll mainly find in India's Gir National Park, is actually slightly smaller than the African lion. And if you look closely at the males, the Asiatic lion sports a sparser, much shorter mane, which means their ears are usually fully visible. Oh, and they also have this really distinctive, almost fashionable skin fold running right along their belly. That's a feature you generally won't see on their African cousins.
Moving on to Part 2, protecting our ecosystems. Because, of course, animals don't just exist in a vacuum, right? To protect these species, we absolutely have to protect their habitats. India currently manages 13 massive, internationally recognized UNESCO biosphere reserves, and a really major recent milestone was adding the high-altitude cold desert biosphere reserve in Himachal Pradesh. Sitting way up there in the rain shadow zone of the Himalayas, this incredibly harsh, dry climate is a crucial sanctuary for some really elusive predators, like the snow leopard and the Himalayan wolf. Now, enforcing protection across all these varied landscapes requires some seriously robust legal frameworks. The Wildlife Protection Act of 1972 is the backbone here, but the crucial update you need to know about is the 2022 amendment. Basically, it cut through a lot of the jargon and streamlined a notoriously complex scheduling system. It consolidated the whole framework into just 4 main schedules. Schedule I is for the absolute highest level of animal protection. Schedule 2 offers slightly lesser protection. Schedule 3 is specifically for plants, and Schedule 4 is dedicated to species listed under CITES. That's to strictly regulate international wildlife trade.
Geographically speaking, this legal protection relies heavily on a dual-zone strategy. India's 58 tiger reserves perfectly exemplify how this works. You have the strict, inviolable core area. This ensures the critical breeding habitat remains entirely untouched by commercial activity. Meanwhile, the surrounding buffer area absorbs the human impact. It acts as a sustainable use zone where things like regulated eco-development and limited tourism can actually coexist with conservation. It's all about balance.
Let's shift gears to Part 3, Global Climate Action.
So, zooming out to the global stage for a minute. Because local reserves, they're still deeply vulnerable to planetary-scale changes. That's why we rely on international governance, like UNCLOS, which is often referred to as the Constitution of the Oceans. It establishes exact, standardized sovereign boundaries. For instance, a coastal state has full sovereignty over its territorial sea, up to 12 nautical miles out. Further out is the exclusive economic zone, granting sovereign rights for resources up to 200 nautical miles before eventually giving way to the high seas. It literally regulates our ocean space.
And frameworks like UNCLOS are absolutely vital right now, because frankly, we are pushing the Earth's systems to their absolute limits.
We operate within what are called planetary boundaries. These are 9 ecological thresholds that define the safe operating space for humanity. But here is the alarming fact. Recent data shows that 7 out of these 9 boundaries have already been transgressed. I mean, just recently, the boundary for ocean acidification was crossed for the very first time. We are now officially operating way outside the safe zone.
And operating outside those safe zones for too long? That pushes us right into climate tipping points. These are critical thresholds where a system undergoes rapid, self-perpetuating, and often completely irreversible change. To really bring the stakes home here, we are seeing this happen in real time. Warm water coral reefs, for example, have recently crossed a thermal tipping point driven by intense marine heat waves. And that's triggering mass bleaching events and massive, irreversible diebacks all across the globe.
Which brings us to part 4, the pollution problem.
So, what exactly is driving us toward these terrifying tipping points? Well, while carbon dioxide usually dominates all the headlines, the silent heavyweight in the room is actually methane. Atmospheric methane concentration has surged to more than double its pre-industrial levels, and the crucial point here is that over a 20-year period, methane is actually over 80 times more potent than CO2. It's an absolute powerhouse. It's the second biggest driver of climate change, independently causing about a third of all global warming.
Using India's 4th biennial update report as a case study, the battle lines for these emissions become incredibly clear. The energy sector is the massive culprit here. It's independently responsible for over 75% of total greenhouse gas emissions, followed pretty distantly by agriculture at roughly 13.7%. And when you break down the gases themselves, carbon dioxide makes up over 80% of the pie, with methane following at 13.3%. So the data is stark. We know exactly where the problems lie.
Now for some good news. Part 5, Powering the Future.
Now, this is where we pivot to the solutions. We've seen the tipping points, we've looked at the grim emissions data, but human innovation is actively tackling these massive problems. One of the most exciting frontiers right now is hydrogen fuel, but it's super important to differentiate it by its color. While gray hydrogen relies on fossil fuels using natural gas, green hydrogen, which is generated through electrolysis, powered entirely by renewable energy, is the zero-carbon holy grail. It's so vital that massive initiatives like India's National Green Hydrogen Mission are underway right now to scale its production globally by 2030.
We are seeing a similar spectacular leap in sustainable engineering with biofuels. We have rapidly evolved away from first-generation feedstocks like wheat and sugarcane that actually competed with our human food supply. The innovation curve moved on to agricultural waste, then it moved to microalgae, and now we are looking at futuristic 4th-generation biofuels that utilize genetically engineered microorganisms to produce clean fuel. It's literally science fiction becoming reality.
And these innovations are translating into massive, real-world milestones. Just look at the sheer speed of India's renewable rollout. By mid-2025, an incredible 51.5% of their electricity demand was met by renewable sources. Plus, the country achieved 51% installed electricity capacity strictly from non-fossil sources. They're now ranking 4th globally in overall renewable capacity. They aren't just hitting targets on paper, they are fundamentally rewiring their entire grid.
We're also seeing huge success in rapidly decarbonizing our existing vehicles. Under the ethanol blended petrol program, India absolutely crushed its ambitious target of 20% ethanol blending in petrol. To achieve this, ethanol production had to scale exponentially. We're talking skyrocketing from 38 crore liters in 2014 to a staggering 660 crore liters. And the payoff is immediate. This E20 blend results in about 30% lower carbon emissions compared to standard fuel.
Wow. Okay. We've covered an immense amount of ground today, from the fragile existence of the sloth bear and the Asiatic cheetah to the strict legal protection of tiger reserves. We've seen how planetary boundaries are literally being shattered by potent gases like methane. But we've also seen the incredible promise of green hydrogen, advanced biofuels, and massive renewable energy rollouts. The sheer scale of human ingenuity is finally starting to match the scale of our environmental crisis, which leaves us with one final provocative question. We have the targets, we have the treaties, and we clearly have the technology, but will we deploy them fast enough to beat the biological clock? Thank you so much for joining me on this explainer. Keep asking questions, stay curious, and I'll see you next time.